Hi guys and girls, and welcome to Magic. This is the first YouTube video in a series of videos where the purpose is to teach you Hyperlambda, the programming language primarily. Now, there's a link in the description of this YouTube video to an article where you can find the code I'm using in this video. However, I need to emphasize that you can watch a million YouTube videos where I am writing Hyperlambda. Unless you manually write it yourself, you're never going to learn it. Why? Because there's this thing called tactile learning. You actually see it when you're at the ATM sometimes and you don't even remember your PIN code, but your fingers remembers the PIN code. Programming is no different in any ways whatsoever. So I deeply encourage you, if you're serious about learning Hyperlambda, to not copy and paste my code, but rather manually write it, at least to try. So I have one cloudlet here. It's recently created backend cloudlet. I'm going to log into it, to which point I end up in my Magic dashboard. Then I'm going to go to Tools, and then I'm going to go to Hyper IDE here. Now, Hyper IDE is an integrated development environment. Of course, it's not like Visual Studio or Visual Studio Code or Rider or PHP Storm or anything like that. But it's very good for Hyperlambda development, and that's exactly what we are going to be doing in these videos. So click the modules folder here, and then click these three dots here, action menu. Find active folder and choose new folder. Then name your folder tutorials, and then click create. So we now have a new folder. Let's select that folder. Let's click the action button again. This time you also choose active folder, but you create a new file and call your file tutorial01.get.hl. The file name here is important because file names have semantic values in Magic. I'm going to show you in a couple of seconds exactly what that means, but just make sure you, at the very least, end your file with .get.hl. Let me zoom out and create my file. So we now have a Hyperlambda file. Hyperlambda files ends with .hl. Now we can create our first endpoint. The simplest way to do that is actually to write return, character return, tab, result, colon, hello world. If you now click Alt S if you're on a Windows machine, you can click Alt S. If you're on a Mac, you can click Option S. Option is always the alternative to Alt on a Mac. However, I might sometimes only say click Alt S or Alt M or etc. So then you have now saved your file. So you have your own file system on your backend cloudlet. And this file here now is saved on that file system. If you now click F5 or you choose this guy and you find active file and you choose invoke, then what's happening is that the model window comes up like this, and you can actually invoke your endpoint. And as you can see, we have now created an HTTP endpoint. We see its verb here being get. The reasons for that is because of what I said a couple of minutes ago, where the file names are semantic in nature. If you look at the name of your file here now, you see that it ends with gets, right? So the verb that your Hyperlambda files obeys by can be get, post, put, patch, or delete. And these are the 5 basic verbs of the HTTP protocol. And which verb one file responds to depends upon what verb it ends with. So if I want to have a patch file, then it needs to end with patch.hl. If I want to have a post file, it needs to end with post.hl. HL, of course, means Hyperlambda. If I want to have a put file, it needs to end with put.hl. However, I'm going to be using get. So we now have an HTTP endpoint. If we click F5 again, we copy the link in location, we can immediately open up an incognito window. As you can see here, the URL is tiger, being the name of my cloudlet, dash poltergeist being my username in hub, .gb implying Great Britain because this particular cloudlet happens to be in London, and then ista.com, and then /magic /modules/tutorials/tutorial01. If you remember the name of the file was tutorial01. Let me just illustrate that here, tutorial01. If you look at the ending extension here, it's tutorial01. If you look at the second last part of your file, it's called tutorials. If you look at the name of the folder, tutorials. Then you see modules. That is the next folder upwards in the hierarchy. And then the final piece of the puzzle is this magic thing, and that is actually a static, literally a magic string, basically telling the HTTP resolver in the magic backend, this is a dynamically resolved Hyperlambda file, please treat it as such. Then it will find its folder and its name, and then since it's an HTTP GET invocation, it will add .get.hl and then actually find the end resulting file. And as you can see, of course, the endpoint is perfectly executing and is actually returning data. So let's add arguments to this particular endpoint. .arguments, carriage return, tab, name, colon, string, then save the file. What I'm basically telling the Hyperlambda execution engine now is that this particular endpoint can optionally take an argument. Since it's an HTTP GET endpoint, that argument needs to be passed in as a query parameter. And the name of the argument is name, and the type of it is string. So inside of my Hyperlambda code here now, I can actually treat this as a string. I know for a fact it will be a string one way or another. Even if I'm passing in non-string values, it will be converted into a string. If I now click F5, you see here now the data retrieval parts of Magic automatically finds that this particular endpoint takes an argument being name and actually populates my arguments collection here. Of course, we're not using the argument now, so it doesn't really help to invoke it. So let's make sure we are using the arguments by doing exactly as such: strings.concat, carriage return, tab, dot, colon, 2 double quotes, hello there, space, go to the end of the line, carriage return, get dash value colon x colon at dot arguments slash asterisk slash name. And then we can further down here write x colon strings dot concat. And then we put an alpha in front of it. We now write unwrap here like this. Then what we are basically doing, we are forward evaluating this expression. And this expression, of course, leads to this node. This node happens to be a Hyperlambda slot invocation that basically concatenates these two strings, hello there being a static string, and get value, this thing, retrieves the value of the argument we passed in. We can now save the file with Alt-S, click F5, pass in an argument, Thomas Hansen, carriage return, invoke the endpoint, and ta-da, here we are. Hello there, Thomas Hansen. So we have now created our first hello world endpoint that actually contains logic. Now, if we want to, we can now go and add another argument, call it age colon int. Then we can go down here below get value. We can write dot colon 2 double quotes, comma, you are carriage return get dash value colon x colon at dot arguments slash asterisk slash age carriage return dot colon 2 double quotes space years old. Save the file, execute it, pass in our name, Thomas Hansen, pass in our age, 42, invoke it, and now you see, hello there, Thomas Hansen, you are 42 years old. And if you look carefully at the age here, the reasons why I wanted to do this is because if you look carefully here, you will see that the Hyperlambda execution engine automatically recognizes that this argument is of type string, and this argument is of type int. So we're going to dive into types later in a later video, but just realize that the metadata retrieval process of Magic automatically determines what types your arguments are, and etc., etc. And as you're invoking the endpoint, it is automatically converted into a type. So if I type something that's not a legal int, such as this, for instance, because it's an overflow, I will actually get an error here. Guru meditation, come back when universe is in order. And the reasons why I wanted to do this is because I now want to show you the log. Because the actual error message is never returned by Magic for security reasons. So I can open up my log here in a different tab. I can go to my log, and here you see input string was not in a correct format. If I have a shorter integer, of course, everything's going to be kosher, right? I'm still a little bit old though, but okay, it actually works at least. So that is the hello world endpoint. So now we want to look at the syntax of this. However, we want to use another tool in Magic. So we're now inside of HyperID. If we expand MISC here, you will find a component called the Evaluator. So what is the Evaluator? Well, first let's click it and have a look at it. And as you can see here, it allows you to execute Hyperlambda in immediate mode. What that basically means is that I can write any amount of Hyperlambda in here, and click execute, and Hyperlambda will immediately execute. So let's create some Hyperlambda. Dot foo, foo1, bar 1, foo2, bar 2, foo3, bar 3. Carriage return, shift tab, de-indents. Dot foo2, carriage return, tab indents, foo4, bar 4, carriage return, tab, foo5, bar 5. This is actually Hyperlambda. Now, obviously, it doesn't do anything, right? But it's still valid Hyperlambda. The reasons for that is because Hyperlambda is actually just a file format. The same way JSON is, YAML, HTML, and XML. And it's actually very similar to these file formats. Because what we are describing when we are writing Hyperlambda is actually a tree structure or a graph object. Graph object is the technical term for a tree structure. And here we have one thing that you can't see. It's always there, but it's invisible. And that is the root node. The root node is outside here, and it's invisible. This root node, just like all nodes in Hyperlambda, has three characteristics. It has a name, it has a value, and it has a children collection. This root node again has two children, .foo and .foo2. If we go into .foo here, you will see it has 1, 2, 3 children again. If we go into .foo2, it has one child. If we look at that one child of the .foo2 node, then that one has another child again of itself. Now, this node here does not have a column like this. That means it has a null value. It doesn't have a value. However, this node here, if you look at it, it writes foo, column, bar 1. This is the node's name. Everything that's to the left-hand side of the column is the name of the node. Everything that's at the right-hand side of the column is its value. And the value can be either a string or an integer or datetime or a boolean or whatever. And we're going to go through that in a later video, exactly how to declare different types. However, the default type in Hyperlambda is always string. So this here is the same as writing this, which again is the same as writing this, which again is the same as writing this. So the end result becomes the exact same if I'm writing this or if I'm writing this. And one little detail here, if you have a syntax error in your Hyperlambda, because if you count from foo1 and backwards, the number of spaces, you will see 1, 2, 3 spaces. A syntax error might be that you, for instance, have one space too much, then your code ends up looking like this. It becomes red from the point where you had that additional space. Why? Because the Hyperlambda will choke, a Hyperlambda parser will choke at this point and not be able to parse this. as legal Hyperlambda. Then again, all of these keywords, if you delete this code, or actually we can keep it, if we now click control space or function control space on a Mac, you get autocomplete. These are all the keywords or functions or whatever you want to call them in Hyperlambda. And there's like hundreds of these. There's like if and more than or equal, NEQ, not equal, not exists, not null, null, or reference, etc., etc. Now, each of these keywords are basically logical pieces of functions that we can invoke. So if we now, for instance, actually, let's keep this thing, right? Dot dest, and then we write carriage return for dash each colon x colon at dot foo slash asterisk adds colon x colon at dot dest carriage return tab get dash nodes colon x colon at dot dp slash hash, and we now execute this code. We are now invoking this function, and we're invoking this function, and we are invoking this function. And the result of this, if you carefully look at the .dest node here, is that we basically added every single node from the .foo section into the .dest node. This allowed us to copy nodes from one source and put them into another source. We're going to go into the add keyword and the get nodes and the forage keywords in later videos. But basically what we're doing here, we're creating a loop that says for every single child node of .foo, add it into .dest. And that's exactly what's happening. Now, if you look carefully here, you will see that .dest here is black. Why? Because it's not a keyword, while for each is orange. So if you don't manage to make it for orange by having an error like this, then you will see that you get black text because the Hyperlambda parser can't recognize it as a keyword. So, and one crucial thing, you see, the Hyperlambda execution engine will try to execute everything. It just assumes everything is an executable function one way or another, except if it starts with a dot, right? You see, in Hyperlambda, there's no difference between data and functions, data or logic, code or data. The difference doesn't exist, and this is crucial. This is why the Hyperlambda programming language can very easily dynamically create code. This is its purpose, so to speak. So this creates a dilemma for us because we might have some data somewhere that we only want to treat like data that we don't want to execute. Well, if you do, write a dot in front of whatever name you want to give your node. It can be anything really. And you have a data segment, right? And in fact, if you try to, remember we executed this, Hyperlambda was executed successfully. If you remove the dot on .foo and try to execute it, you will see no slot exists for foo, right? In fact, let's try to execute it again and zoom in. No slot exists for foo. The reasons why is because the Hyperlambda execution engine will try to execute this as if it was a slot. That slot doesn't exist, so it will result in a null reference type of exception during execution of your code. So remember this, each node contains of three things: a name, a value, and a children node collection, right? Here is the node's name, it has a null value. Here is a child of the .foo node, 1, 2, 3 spaces. The name of the first child of the .foo node is foo1, then comes a colon separating the name of the node and the value, and then comes a text bar1, implying that bar1 is the value of the foo1 node. So now that we have the code, let's create a reusable object out of the code. So the first thing you want to do, you want to click save here, and then we can give our snippet a name. We're going to call it tutorial 01-01, right? Because it's the first tutorial and it's the first snippet we're saving. So then click save, and now you can go to HyperID and open up modules, expand tutorials, and open up your tutorial1.get.hl. And now there's a really cool thing happening if you click Alt-V or Option-V on the Mac. And that is that if we filter here now, we have our snippet, and we can actually insert it in. This works like an extended copy-paste, you might say, allowing us to do some intelligence by combining the snippets we have saved in our evaluator and using these snippets inside of HyperID. But let's not put it here. Let's create another file. Make sure you have selected the tutorials folder, then click the triple icons, click active folder, click new file, and call your file tutorial02.get.hl. Right. And now we want to give some space here. Now we want to click Alt-V. We want to choose our tutorial 0101 snippets. And then at the bottom here, we can further add code to whatever it does. And that code is going to be return : x : at.dest /* like this. Then save the file, Alt-S, click F5 and invoke it. So what is happening here now? Well, we are actually we're having the foo segment here in our Hyperlambda endpoint. This foo segment has 3 nodes. Then we are looping through all of these nodes. We're adding these nodes into the .dest nodes. And then at the bottom here, we are returning every child node of .dest. And the reasons why this works is because this expression, if you look closely at it, and we are going to dive deeper into expressions in later YouTube videos, but I'm going to show you just the basics of how this particular expression works. The alpha here says basically find the first node whose name is .dest upwards in the hierarchy. What is upwards in the hierarchy? Upwards is this way. So when it comes up here, this iterator, now expressions are created by iterators. This iterator yields a match and it returns this node. This node has a bunch of children at this point. Why? Because we moved or copied the nodes here and pasted them into here. Or we iterated over the nodes in .foo and added them to the .dest. So when we come down here, .dest actually has a bunch of children nodes, and we can actually verify that by doing like this, shift tab to de-indent, lambda to hyper : x : ... * log.info : x : -. Then let's save the code, let's execute the endpoint, invoke it, then close this screen, open up MISC, open up log in a different tab, and go to our log. And here you can see Dest has 3 nodes. So anyways, that was it for the first video tutorial. There's a link in the description of this video to an article where I will be having the code and having written description of what this particular YouTube video does. You can click it if you want to copy paste my code. I encourage you yet again to not copy paste code, but rather manually write it, because there's this thing called tactile memory, allowing your fingers to actually become an extension of your brain and your memory. However, if you only want to copy paste the code, you can find a link in the description of this article in this YouTube video to an article where the code is published. Remember to like the video, subscribe, hit the bell, share the video with your friends. Thank you for watching. Have a nice day.